Hello, I'm Papia. In this problem, we have to evaluate a definite integral. And it is the integral from -4 to 5 of the function x squared minus 4 over x plus 2. Now, the first question is, we have to find all the x values where this function may not be continuous. So, this is our function, f of x. So, let's see if the function is discontinuous at any point. The function is x squared minus 4 over x plus 2. So, you notice that there is a denominator, and therefore, wherever the denominator will be 0, function is not continuous there. And where is the denominator 0? Where the factor x plus 2 is 0. Therefore, f is not continuous at x plus 2 equals 0 means x equals -2. So, this is the point where the function is not continuous. Why do we need that information? Notice that this x value lies inside the interval -4 to 5. So, we have to be careful about evaluating this definite integral. Okay. So, in order to evaluate the integral, that's the next step, we should first graph the function. We have to understand what the function looks like, what happens at this discontinuity, and then we will think about evaluating the integral. Okay, notice one more fact. What happens for all those values that are not -2? So, if x is not -2, then look at the function expression one more time. So, our expression is x squared minus 4 over x plus 2. Notice that the numerator is a difference of two squares, so you can factor it. And the factors are x minus 2 and x plus 2 divided by x plus 2. And since we have common factor, both numerator and denominator, we can cancel it, right? But notice, we can only cancel because we are assuming that x is not -2. So, this factor is not 0. Only those places we can cancel. So, this function is actually the line x minus 2 everywhere except x equals -2. So, it should not be too difficult to graph the function. It's actually a line. So, what is happening at x equals -2 where it is actually not continuous? Well, it will have a hole in the graph. That's what's happening. So, let us graph the function between -4 and 5, and then we will think of evaluating the definite integral. So, like I said, this is just a line, x minus 2. So, at x equals -4, let's say this is -4. What is the y value? Well, -4 minus 2, so -6. So, say this is -6. So, at -4, the function value will be -6. At 5, 2, 3, 4, so this is 5. The y value is 5 minus 2, so it will be 3. Okay, it's a line, but remember, the line is not actually continuous at -2. So, if it were continuous at -2, the value would be -4, but it's not. So, here is -4. So, what's happening? At -2, you will have a open circle in the line. Okay, so let's try to graph. So, it's a line x minus 2 everywhere except at that one point where you have a hole. So, this is what the function looks like. Okay. Now, let's consider evaluating this integral. So remember, we can evaluate a definite integral for a continuous function. This is not continuous. So we have to integrate from -4 to 5 the function, which is given right here. So we can do it this way. We can break it up into certain intervals. So we can integrate from, say, -4 to -2. That's where we have the discontinuity. And then we integrate from -2 to this point. This is where the line is crossing the x-axis, and this is 2. So -2 to 2. And we integrate from 2 to 5. So these are 3 separate definite integrals. How do we get the original one? You just add all of these, right? That's a property of definite integral. Now, let's think about it. How do we compute each integral? Okay, so notice that between -4 and -2, when you find this definite integral, you are actually considering this region. And the definite integral will actually give you this area. But the area is underneath x-axis, so you will have a negative of the area, right? Okay, how do we compute this area? Well, this is a trapezoid. So we can just use the formula for area of a trapezoid. Notice that there is a hole in the graph of the function, but that doesn't affect this area of the trapezoid. So we can just find the area of the trapezoid, and that will be this definite integral, the first one. Of course, the negative area. Okay, so this one is the area of trapezoid. So remember how to compute the area. Half times, we find the height, and which is this length, and this is 2, times the sum of the lengths of the parallel sides. Okay, so this length, you see this is -6, and this one is -4. So it's -6 plus -4. And I kept it negative, even though they're lengths, because I know that my area will be a negative area for this particular definite integral. And so this is, the 2 will cancel with the 1/2, so this is going to be -10. All right, now for the second definite integral, this is from -2 to 2, which will give you the area of this region. Again, this region is below x-axis, which means you will again have a negative area. So notice this is just a triangle, a right triangle. So you know how to compute the area. This is half times base, the length of the base, which is -4, times the length of the height, and that's 4. So this is equal to -8. Finally, the last integral is from 2 to 5. So 2 to 5, this is the region. Now this is on the positive side, above x-axis, and so it will give you a positive area. And notice that this is also a right triangle. And the area is half times length of the base from 2 to 5, so that's 3, times the height is also 3. So this is 9/2. So what is the original definite integral? It's the sum of these 3 numbers. So it will be -10, -8 plus 9/2. So that is -18 plus 9/2. So if you do a common denominator, it will be 9 minus 2 times 18, that's 36 over 2. And that is negative 27 over 2. So the definite integral from negative 4 to 5 of the function x squared minus 4 over x plus 2 is negative 27 over 2. We complete the problem by verifying our result using a graphing utility. So you put your function as y equals, so it is x squared minus 4 divided by x plus 2, and then use calc and go to the integral of the function, hit enter, and then it's asking for the lower limit. So you give the lower limit x equals negative 4, then upper limit is x equals 5. And so the area is negative 13.5. Look, 27 over 2 is 13.5. So we have correct answer. This completes the problem. Thank you.